PQNK versus conventional sustainable farming approaches. Feature PQNK, conventional approaches, CA, RA, SA, RAP. Core philosophy. Mimics natural ecosystems, focusing on soil microbial health and biodiversity. Often integrates some sustainable practices but still relies on synthetic inputs or partial interventions. Soil health management. Encourages aerobic microbial life by maintaining air-water balance, organic mulch, and zero tillage. Often includes reduced tillage but may not fully restore soil microbiology. Water management. No inundation of soil, water seeps laterally through furrows, ensuring optimal air-water ratio and soil pores. Some methods still use excessive irrigation or do not account for optimal microbial conditions. Nutrient cycling. Utilizes plant residues as organic mulch, ensuring continuous nutrient recycling without external inputs. Often relies on compost, biofertilizers, or minimal external amendments. Pest and disease control. Relies on natural predators, over 1,700 identified species, and microbial balance to prevent pest outbreaks. Still dependent on some level of biological or chemical pest control. Crop productivity. Ensures nutrient-dense food production without external fertilizers or chemicals. May focus more on yields rather than nutrient density. Machinery and adaptation. Custom-designed farm machinery to facilitate easy adoption of PQNK. Many sustainable practices lack tailored mechanization for ease of use. Introduction. Peter Tradinizam Kashata Kiari, PQNK, is a regenerative and sustainable natural farming system developed over 50 years. Unlike conventional sustainable agriculture approaches such as conservation agriculture, CA, regenerative agriculture, RA, and sustainable agriculture, SA, PQNK is based on a deep understanding of nature's self-sustaining mechanisms. Many organizations have adopted buzzwords like CA, RA, SA, and regenerative agricultural practices, RAP, without fully understanding or implementing the underlying principles that make natural farming truly work. Key differences between PQNK and conventional sustainable farming approaches. Why PQNK works more effectively. Microbial balance and soil restoration. PQNK creates an ideal environment for microbes to thrive, ensuring nutrient availability and plant health. Pest resistance without chemicals. Bt, Bacillus thuringiensis, is a microbe naturally found in soil. It makes proteins that are toxic to immature insects, larvae. There are many types of Bt. Each targets different insect groups: sucking, chewing, eating, caterpillars, bollworms, beetles, mosquitoes, flies, and moths. Further, presence of natural predators eliminates the need for pesticides, including Bt/GMO interventions. Water and air balance in soil. Permanent beds with lateral water seepage maintain optimal conditions for soil life. Energy-efficient farming. PQNK's approach requires less mechanical intervention, reducing energy consumption and labor. Complete elimination of external inputs, unlike CA, RA, SA or RAP, which may still require compost, manure, or other amendments. PQNK achieves full sustainability by working within nature's cycles. Conclusion. PQNK is not just another sustainable farming approach, it is a fully self-sustaining, nature-aligned system that has been tested and proven by thousands of farmers. Unlike conventional sustainable farming models, PQNK ensures efficient production processes, custom farm machinery, and a holistic approach to ecosystem restoration. Farmers practicing PQNK do not need external inputs or interventions, making it the only truly regenerative and sustainable agricultural model.